October 1st marks the International Day of Older Persons. Both the United Nations and the World Health Organization have dubbed the next decade as the Decade of Healthy Aging and have proposed a 10-year action plan. Moderated by Tkach Tuzman, Head of Discovery and Preclinical Development at BioCentury, our guest speaker, William Hait, Global Head of Johnson & Johnson External Innovation, will shed light on the decisive role of knowledge and collaboration in conquering barriers in geriatric healthcare, as well as precision medicine, and how we can accelerate the pace of innovation.
Thank you, everyone, for joining us today. My name is Tkach Tuzman. I'm a senior editor at BioCentury, and today I'm joined by Dr. William Hait, Global Head of Johnson & Johnson Global External Innovation, where he leads external sourcing and creation of transformational innovation to help Johnson & Johnson achieve its mission to change the trajectory of health for humanity. And Dr. Hait joined J&J in 2007 and served as Global Therapeutic Area Head for Oncology from 2009 to 2011, and then as Global Head of Janssen Research and Development from 2011 through 2018. So thank you so much for joining me today. Maybe to kick off the discussion in light of the UN Healthy Aging Initiative, I'm wondering how you view industry's approach to healthy aging, how you're seeing it evolving over time. What's changed over the last 10 years specifically? And what do you think the next 10 years will look like across industry and especially at J&J?
Yeah, hi, Karen, and thank you so much for having me and for the question. Let me give you a sense of how we see this issue of healthy aging at Johnson & Johnson, and even share a partnership what we've entered into with the National Academy of Medicine in their Healthy Aging initiative. It really began by us understanding that the world's population is aging. And as we age, like it or not, we begin to accumulate a series of unwanted companions called chronic diseases as we go through life. But we asked the question, well, what if we could enjoy life free, aging, free of disease? And we called that immorbidity, a term coined by one of our colleagues at J&J, now at Harvard, named Jaap Goudsmit. And we said, okay, how would we go about envisioning this world without disease? So we put together a group from across J&J, from our consumer health group, our medtech group, our pharmaceutical group. We sent them off and we said, okay, tell us, how are we going to create a world where there's healthy aging, a world without disease? And they came back and they said, okay, well, we'd like to be more like our cars. We said, really, how so? They said, well, our cars, when the car rolls off the assembly line, all the specs are known. And the car is embedded with sensors that are monitoring all of the vital systems. And when the car goes out, begins to go out of spec, the check engine light comes on, and the data are downloaded into a computer, and adjustments in the car are made before it ever breaks down. Well, we want to be the same. When we roll off the assembly line, we'll soon know all of our specs, all the diseases to which we're susceptible. And we'd like to be censored as well with wearables, implantables, even invisibles. And if we begin to go out of spec, we would like our check engine light virtually to go on and our information downloaded, say, into an IBM Watson-like computer, and adjustments made to us so we never become ill. And we live this life that we would love to live free of disease. And that's what we've called immorbidity.
I really appreciate that concept. And I wanted to ask you, oftentimes when people think of aging-related diseases, they might think about Alzheimer's, cancer, stroke, but you mentioned sort of a check engine light for a broad spectrum of health and disease indicators. So what are different aspects that you imagine these sensors detecting and different indications that you think will be important to address for healthy aging?
Yeah, but one other thing, some of the big diseases as well as the cognitive impairment that people often experience, not everyone, but many as they age, are other diseases that we're all aware of, like cardiovascular disease, diseases of wear and tear, osteoarthritis, where you wind up replacing your knees or your hips, and things that are extremely painful. And what we understand is that these diseases begin very early in life. They don't suddenly occur when you're in your 70s or 80s or 90s. They've begun years ago. And this model would begin to detect when some of these processes, when we are embarking on a disease-causing process, so we could intervene. It turns out that a surprising number of these chronic maladies that we deal with are associated and perhaps caused by chronic inflammation. So if you think about the new concepts of Alzheimer's, where the thinking that there's a neuroinflammatory component, cardiovascular disease, where CRP and chronic inflammation is a risk factor. It turns out that obesity is a risk factor for chronic inflammation, that adipose tissue is very pro-inflammatory. So the areas like chronic inflammation and one step further to autoimmunity, these are areas that are predecessors to more serious diseases. And we think intervening early and intercepting these disease-causing processes will hopefully prevent us from becoming ill.
And you mentioned inflammation, and I'm wondering what kinds of biological pathways you see emerging as key sources of targets for aging-related diseases, and what kinds of technologies are poised to help address those pathways?
Yeah, well, we saw an absolute remarkable result with a drug that targets IL-1 beta, an antibody that targets IL-1 beta, not from our company, another great company, Novartis. Their study, where they looked at 10,000 people at high risk for developing cardiovascular disease, and asked the question, if you blocked inflammation with a very potent anti-inflammatory drug, like an anti-IL-1 beta, would you have a positive effect? And yes, you do, you have a positive effect. What was most remarkable from many people's point of view was that group of 10,000 patients that they studied were at very high risk for lung cancer because they were often heavy cigarette smokers. And although none of them had been diagnosed with lung cancer when they entered the study, there was a remarkable decrease in lung cancer in those treated with an anti-IL-1 beta. And in fact, there was a beautiful dose-response relationship giving you the confidence that this observation was true. So it was, of the many things we've seen over the years, perhaps the most recent example of how interfering with chronic inflammation might have generalizable effects. It might have effects on cardiovascular health. It might have effects on cancer. It wouldn't surprise me at all if there were other things like that. So there are emerging data with a clearer understanding of the aspects of inflammation that could be very, very important. And IL-1 beta is part of a very, very important area of biology that includes targets like NLRP3, the inflammasome. The inflammasome has evolved in us to deal with particulates that cause inflammation. And so it's set up to deal with these things, and we can then target them and ramp down the process with a whole new area of biology based on an area of our cells called the inflammasome.
And one thing, going back to what you mentioned about the check engine lights, the idea that we can maybe detect signs of trouble before they really, before our car gets stranded on the road.
Right.
One thing is that our health system has generally functioned around a paradigm of diagnosing disease once symptoms are apparent. And there's been historically less emphasis on screening in asymptomatic cases. But one thing we're seeing with the pandemic is that screening of asymptomatic people is becoming very important for public health. And then at the same time, we're seeing an emergence of early cancer detection tests that could broaden screening paradigms. So I'm curious how you think about the role of screening tests for healthy aging, and maybe some activity at J&J that you wanted to highlight around that.
Yeah, it's absolutely critical. I think what you're referring to is we really don't have healthcare, we have disease care. We wait, and think about it. 100 years from now, people are going to say, these people, our ancestors, used to wait until they got a disease, until they did something about it. They're going to say, are they out of their minds? And that's what we do for many, many things. On the other hand, some of the most transformational opportunities have been interception plays, disease interception plays, or prevention. So we don't have to go too far to think about vaccines. And infectious diseases, of course, have been the leader in preventatives with these incredible vaccines, going way, way back, but certainly what we've seen with SARS-CoV-2 and COVID-19, extraordinary. But in the field of cardiovascular, the major impact of the statins and now the PCSK9s to intercept the disease-causing process. We don't wait until we have a heart attack or a stroke to start doing something about it. We should be thinking this way about all of our major diseases and minor diseases. Why wait to be diagnosed? So one of the areas that we're very interested in are pre-malignancies. So multiple myeloma, a terribly devastating disease, has a pre-malignant condition called smoldering myeloma. And even smoldering myeloma has a pre-condition called MGUS. And we've begun asking the question, number one, can these things be diagnosed easily? And the answer is yes. And number two is, can they be treated? And the answer is yes, too. And we have to conduct the studies to get the data. They're ongoing. But there's no question in my mind, in the field of oncology, for example, that the earlier you get at these problems, the better the outcome is going to be, because as the disease evolves, just like we're seeing with COVID, it gets more complicated. And so it's extremely exciting. The other one of real potential is type 1 diabetes. Juvenile onset diabetes is horrible. These kids, often infants, are now destined to a life of monitoring their glucose, injecting themselves with insulin. Even with the latest, greatest devices, it's still a horror show. And yet, you can predict who is going to get type 1 diabetes through very simple blood tests, because they develop autoantibodies. And if you develop more than 1, 2, or even 3 autoantibodies, you're going to get type 1 diabetes. And the question is, what could be the interception? What drugs would stop you? All of these things are possible. All you have to do is scratch the surface, get a group of people just as dedicated to treating diseases and discovering how to treat disease, get that same group, refocus them on how to intercept disease-causing processes, and that will be transformational.
And J&J has really been at the forefront of pioneering the concept of disease interception. And oftentimes when we think about disease interception in the general public, we think about the diet and exercise things that we should be doing, and maybe we do a little, but maybe not so much. And in general, I think the paradigm of taking preventative action, particularly if there is a high cost associated and there's no problem yet, can be a tough paradigm to advance broadly in terms of people's willingness to participate, et cetera. So I'm wondering what approaches you see as most promising for intercepting diseases and aging-related disease in particular, both in terms of the efficacy they could provide, but also in terms of the likelihood of compliance.
Yeah, man, safety. So you raise a really critical point. And the answer to your question is, I don't know. And the reason I don't know is we don't have enough knowledge. So I could say, take more vitamin X, Y, or Z, and that would be a wild guess. And if I ran a health food store, you could find all sorts of things. But if you compare the knowledge we have about diseases to the knowledge we have about the causation of disease, it's much, much different. So until we know much more about what are the predispositions, what are the predecessors, we're guessing. We're not being precise enough. And the term precision interception or precision prevention is a good one, but we can't be precise without the knowledge. So my urging, not just the J&J, but my colleagues in academia and starting their own companies and all the, in other companies, let's start thinking about this. We can't ignore the fact that people are suffering with diseases, and we still have to focus on treating them. But let's spend a little more time and effort and apply these incredible technologies and these brilliant people that we have to get a greater understanding of what are the predispositions and the predecessors, so we actually can answer your question. Sure, diet, exercise, eat a lot of fruit, great, but let's be more precise, especially as we begin to understand the diseases to which we're susceptible, our loved ones are susceptible, our children are susceptible. Let's get going.
And from the point of view of technologies to enable that, one of the things you mentioned that I got really curious about was around invisibles. When you listed the types of technologies that could be used for this, could you give a bit more color on that and what that means?
Yeah, it's remarkable. It's a technology we've seen that's come out of MIT. The ability of certain levels of energy that are very simple to set up that are interfered with by our movements. So the first thing they wanted to know, using a certain form of energy in a room, could they detect movement? To see maybe they could find some abnormal movement. So they did. It was very easy to detect movement, but they also saw something very interesting. They saw these waveforms, and the waveforms turned out to be respiration. And then at the top of the waveforms, they saw these squiggles, these ratchets, and that turned out to be heart rate. And imagine, and it's complete, it's you're just moving around your house, you're just living, and you can imagine your home where you could begin to detect, not by having an implantable or a wearable like so many of us wear to see if we have an abnormal cardiac rhythm. Imagine that it would be autonomous, and it would be a signal that, give your telemedicine doc a buzz and see what this is all about. And you can imagine the loop. You have the invisible in your home, it's hooked up to a telemedicine group, and now a doctor's office is completely different. It's no longer a waiting room with sick people sneezing on you. It's a bank of computer screens monitoring the invisibles autonomously. And when something's going out of spec, the check engine light goes off and there's an interaction.
And with the couple minutes we have left, you mentioned how really confronting the fact that there is an unprecedentedly large aging population around the world and an urgent need to address aging-related diseases. How do you think the pace of innovation can be accelerated to meet that need?
Yeah, and I thought the question was very interesting because it gets to a fundamental question of how you approach someone to participate in a clinical study. It's never easy, and it takes, and what we've learned over the years is that there are a few criteria that increase your probabilities of improving enrollment. One is, but if they see a peer, someone who has shared experiences in life, who is someone who they can trust, they're more we've learned from studies that those people are more likely to participate in studies when you have that type of recruiter. And the other thing that is critically important, especially for the very young and the very old, is the convenience. If you have to travel multiple times a week or long distances to participate in a clinical study, it's just not going to happen very much. But on the other hand, the more these studies can be virtual, the more they can be real world evidence, the more stuff can be done out of home with a telemedicine or teleclinical research nurse, whatever it will be, the greater the ability to enroll patients, the very young, the very old, patients from diverse backgrounds, to make the system more equitable.
So with your background in oncology in particular, one of the things we've been seeing is an explosion of more precision medicine there, a lot of lessons from oncology that are now other disease indications hope to emulate and learn from as well. Could you share a bit more about that?
Sure. Well, I think it really starts in 1971 when President Nixon signed the National Cancer Act. And almost every university in the US and many around the world have set up cancer centers, which are often multidisciplinary approaches to try to generate the knowledge that could be translated into products. And when you do that for a long period of time, you begin to have enough knowledge that you can have overnight successes. So Gleevec and BCR-ABL didn't happen because Brian Drucker woke up in the morning and said, I can make Gleevec. It was built on years and years of studies going back to the Philadelphia chromosome and the understanding of how things were moved around on those chromosomes to create a fusion gene that created a protein kinase that could be targeted with the drug. That 20 years of hard work, of slugging it out to try to get that understanding, it doesn't happen by accident. It happens because you generate knowledge. And the other piece that really was helpful in oncology, pediatric oncology is a great example, is the cooperative groups, the ability to cooperate on clinical studies. So in pediatrics in particular, when it seemed feasible that acute lymphoblastic leukemia could be not only treated but cured, that was accomplished through cooperation across the country, where people, practitioners, pediatric oncologists, were enrolling their patients in studies. And that one study showed some improvement to the next study, to the next study, and ultimately now we're at these remarkable cure rates for childhood leukemia. You know, it's not magic. It's science. Science appears like magic sometimes, but it's real. And the reason it's real, it's based on knowledge, generation of data, which leads to real facts, and then you can be more precise.
Well, thank you so much. I really appreciate the time to connect today. And thank you to everyone who tuned in, and hope you have a great rest of your day.
Thank you, Karen. I enjoyed being with you.